So now that we've seen how to store data in a very low level way in Git, normally we use a whole bunch of other commands and Git hashes things for us, but we can manually tell it, hash this, turn it into a Git object and store it. So we've done that a couple of times. And we got these keys back, right? We have this one and this one. So imagine that I don't know what was stored in there, or it was a really long file that I stored. I want to retrieve that data out. I have the key, and Git is storing the information in these files. I just can't read them. So to get it out, there's a function, or there's a Git command called cat file, git cat file, and then we pass in an object hash. So that could be a commit hash, or it could be one of these hashes. This is not from a commit. It's from something called a blob. We'll go into more detail. But any of these hashes we get in Git, they all are tied to a Git object, one of 4 types. And we can get information, we can read them out using git cat file. Now this -p option tells Git to pretty print the contents of the object based on the type of object it is. So I could pretty print a commit. If I had a commit, using -p, it would detect it's a commit and print it out as a commit. But we're going to try it with what we have. These are not commits. So I can copy the whole hash and do a git cat file -p. And then I'll pass in the whole thing just to start. And what do you know? It says, hey, I have something stored for that. I have hello. I can also give it way fewer, right? I could just give it a couple of digits and it can figure it out. Let's do our second value that we stored, which was goodbye. We got back DD7E1. Let's just do that. So instead of the whole hash, just that little bit, and it knows what it stored. We gave it the key. It gave us back goodbye. All right. So now what I want to show you is a little bit different. I want to use files. I want to have actually just 2 versions of the same file, both of which we'll be able to store manually using the command git hash object, and then we'll be able to get those versions back out. So let's make our new file. I'll just touch dogs.txt, and then I'm going to open it up in my editor. All right, here it is. And I'll put in some of my dogs, Rusty and Wyatt. Rest in peace, Rusty and Wyatt. All right, so I have one version of this file. If I look at that file, that's what we have in that file. So I can tell Git to hash it. I can do the same thing, git hash object. I don't have to bother with the echo and the standard in because I'm going to provide it a file. I want it to tell me what is the hypothetical hash I would get back if you stored this. I'm not storing it because I didn't do -w. That's what we get back. So assuming that file doesn't change, remember how this works. The same input gives you the same output. Well, that's really important for how Git works because it can very quickly tell, oh, this file hasn't changed. It's giving me the same hash that it had before. But as soon as I change anything, a single space, a capital letter to a lowercase, the entire hash changes and Git can detect that. Anyway, I'm going to store it now. So I'm going to add the -w. All right, so git hash -object dogs.txt -w. And if you're following along here, you can type this exactly as you see it, or just make note of the fact that your hash is different, and just use that hash when we come back to it. So just be consistent, right? If you do follow along with me, make sure you're getting this hash. If you don't, it's not a big deal. Just use that hash that you're getting instead of the one that I have. All right, so I'm going to do -w. I'm saying store this version of that file, dogs.txt, and I'll have to refresh VS Code, but there it is, 39E27, whatever. And that's what it starts with, right? 39E27, blah, blah, blah. So now if I do a different version, if I change what's in this file, Rusty Wyatt, pretend, I'm using Git. We haven't made any commits, to be clear, right? If I type git log, no commits. But if I add another dog on here, Rusty Wyatt, I had a childhood dog named Cheyenne. And how about Sirius Black? Another great dog. Okay, so a new version of this file. If I try hashing that, I won't store it just yet, but if I hash it, we get a very different hash now because things have changed. Small change, any change, should lead to a large change in the output. So still 40 characters, that hash. that we get back from SHA-1 from Git, but it's very different. So let's store that one too. All right, so I'm going to do git hash object dogs.txt -w for write. So we should see a new folder called fd and a file called this, 915, and so on. So whatever you did, if you had changes, you should get a different hash. And in that .git/objects folder, there now is an fd, at least in my example, 915. So I can't read it, but we can use the cat command, right? Git cat file, which if I scroll up, where did that go? We used it recently. Maybe not. Anyways, there it is, cat file. And then I can provide that hash. So either one of these hashes. If I do this, let's take this one, git cat-file, and I provide that hash. Well, it yells at me because I forgot to provide the -p option for pretty print. There we are. So we see the first version. Actually, this is the second version, rather. But if I take the other one, and this is where it gets kind of annoying to watch me do this, but remember, I have two versions. This was the second one. This was the first one. I'll just copy part of that hash. And then I'll do the same thing. Git cat-file-p. I forgot that. This was the other version. So Git is storing both of these. I can delete the file entirely. I could get rid of this file, dogs.txt, but as long as I don't delete .git, it still has both of these versions in there, and I can get them out without even making a commit. I told Git to store those things for me manually. So let's say I delete everything from, let's just delete the contents. I won't delete the entire file. Okay. If I wanted to restore the contents, I'll take the hash that we got back, this one that starts with fd9, just like that. Whatever you got back, copy it. And then let me clear this. I'm going to do a git and then cat-file-p, pass in that hash. But this time, I'm going to add it into that file. Was it dogs.txt? And take a look. It's been restored for me. And if I use the other hash, which I can't remember, but I could even just look in here. I think it was 39E275. We'll see if I'm right or not. Let's see, 39E275. There it is, Rusty and Wyatt. So what I'm doing here is telling Git, please go and take this key, find the corresponding value that was stored under that key, and then take the contents of that file, right? Each one of these files, it's binary, it's compressed, it's encrypted. Take that, turn it back into something that makes sense, and then stick it in dogs.txt. So I could still delete that file, I could empty it out, I could have some radical changes in here, which, I mean, we do this all the time with Git, right? And then we realize, oh, shoot, I want to go back to an older version of this file. Well, Git stores them all in here, not because we're running this command or because we're running git hash object, but it's the same principle. Git is able to hold on to those files, it's storing them in that objects directory, and then at any point, we can say, okay, please go give us that. Let me redirect that into dogs.txt. And we're back to normal. Okay, so we're one step closer to understanding things. We have not made a single commit. Just want to be very clear. We have only hashed things, hashed files and hashed strings of text, and stored those, and we've been able to retrieve them using the hashes we get back. But that's not a commit. In fact, there's something called a blob, and in the next video, we'll expand more on blobs.